All right, we're going to look at properties of quadrilaterals today. So let's have a look at some. Now, quadrilateral is just any four-sided flat shape. Here are some examples. Some of you might have seen these before. You should have anyway. So first one, obviously that's a rectangle. And this one looks like a square. This one over here, all sides are equal. This is called a rhombus. This one over here, this is called a kite. This one down here at the bottom, it's called a trapezium. And what's special about a trapezium, at least one pair of sides are parallel. This one here is called a parallelogram. Parallelogram, okay? And the one down the bottom here, well, that's just some random four-sided figure. We just call that a quadrilateral. Okay, it's got no equal sides necessarily, no parallel sides. But in fact, all of these figures on this page are quadrilaterals because they have four sides. Now, a couple of terms we need to be aware of: opposite sides and opposite angles. Okay, so if you look at side AB first, so side AB is this side here, AB is this side here. So which side is opposite to that? It's DC. Okay, so you need two capital letters there to name the side, so that's DC. Which side is opposite AD? Okay, let's have a look at AD. Here is AD starting at A and going to D. The side opposite that is BC. Okay. BC. All right. Now, let's look at some angles. All right, what side is opposite angle A? All right, so this symbol here should not be a square. That should be the angle symbol there. Okay, let me just fix it up. So that should be the angle symbol. So angle A is up here. Which angle is opposite angle A? Well, it's angle C. So let's write that down. Angle C. Next one, which side is opposite angle B? Okay, that changes to an angle symbol there, angle B. And if you look up here, angle B is here. There it is. So angle D is the opposite angle. All right. Now what about adjacent sides? Adjacent means next to. Okay? Next to. Adjacent means next to. Adjacent sides are next to each other. They share a common vertex. A vertex is just a corner. Okay, so if I take a corner here, corner A, we call that vertex A. There are two sides which are joining that corner. This side here, so this side here, AD, and this side here, AB, they're called adjacent sides. Okay, so let's write that down. AD, comma, AB are adjacent sides. Let's have a look at another pair. So if you take the corner C, which is called the vertex C, two sides which have joined into that corner are the adjacent sides. So you can see that CB is adjacent to CD. So CB is adjacent to CD. Okay, so two sides which are next to each other, they're called adjacent sides. All right. We could also name another pair, for example, AD and DC. So AD and DC are also adjacent. So AD and DC, they're joined by the corner of D, aren't they? So that's why they're adjacent. And the other one we could do is, we did AB and BC. What about BC and CD, which did that? CD and, yeah, CD and DA, which we just did. And then DA and AB, which we did as well. Okay, and then AB and BC are also adjacent, so let's write that down. So A, B, and BC are also adjacent. Okay, so what side is adjacent to AB? Well, we wrote that down already. That's BC. What side is adjacent to AD? AD. Well, actually, we've got a few we could write, couldn't we? So if you look at BC, here's BC. We've got AB is adjacent, and also, sorry, what side is adjacent to AB was BC or AD. Okay, so BC or AD. And then which side is next to or adjacent to AD? So here's AD. So that means we could say for that side, AB is adjacent to AD or DC. AB or DC for that one. All right. Now we're going to use this link here to investigate properties of the quadrilaterals. Okay. So I want you to click on that link there, and that should take you to this page here, the parallelogram. All right. So for the parallelogram, I can move any of these sides that I want, and the angles and sides will change. So what do you notice about this parallelogram or any parallelogram if you look at the properties? Let's look at these sides first. You can see the arrows on the opposite sides, and these two arrows and these two arrows here. So the opposite sides are parallel because those arrows mean that it's parallel. So we come to a little diagram here. What can we conclude about the sides of a parallelogram? Well, the opposite sides are parallel. So let's put a pair of arrows here and a pair of arrows here. And then let's put double here, two arrows there. Okay, so let's write that down. Opposite sides are parallel. Opposite sides are parallel. Okay, and not only they are parallel, have a look. See the blue sides here? You've got 8.2 and 8.2, so the opposite sides are also equal in length. And look at this, the two red sides, 5.1 and 5.1, they're also equal in length. And no matter what I do, no matter how I change that parallelogram, the opposite sides are always equal in length. Okay, so let's write that down. Opposite sides are parallel and equal. Okay, now how do we show that the opposite sides are equal? We use a single dash here to show that those two sides are equal, and a double dash here, and a double dash here to show that those sides are equal. Okay, so I want you to make sure you copy that down onto your page. And then let's have a look at the angles of a parallelogram. Well, you see here I've got 72.6 and 72.6. They're the opposite angles, aren't they? And see here 107.4, 107.4, they're opposite angles too. So we can see that the opposite angles are equal, and this pair of opposite angles are equal too. And no matter how I change my parallelogram, that is always true. Okay, you can see here 63.7 and 63.7, 116.3, 116.3. So the opposite angles are equal. So let's write that down on a page. So opposite angles are equal. So opposite angles are equal. All right, now how do we show that on the diagram? Well, let's do that using the same symbol. So let's have this angle here is equal to this angle here. So we use a single arc for that. And then let's put a cross here. This angle here is equal to this angle here. Okay, so that's done for the parallelogram. So make sure that's copied down onto your sheet. And let's look at the rhombus now. Now, for the rhombus, we're going to go back to our internet page. Now, this little slider here, you're going to slide that up and we get the rhombus. Okay, now let's look at the sides of the rhombus. You see here, this side and this side here have got a single arrow, so they're parallel. And this side here and this side here have got double arrows, so they're parallel. Okay, so for the rhombus, we're going to write down the opposite sides are parallel. So opposite sides are parallel. Okay, so let's put that on the diagram. So we've got a single pair of arrows there to show that these two sides are parallel, and then a double arrows here and double arrows here to show that those two opposite sides are parallel. Okay, now I'm just going to get rid of that full stop there. The other thing we should note about the sides, let's go back here, is have a look at the sides. 6, 6, 6, and 6. All the sides are equal. So for a rhombus, no matter what I do, the rhombus always has equal sides. You can see that there. No matter what I do, every side has the same length. Okay, so let's write that down. Opposite sides are parallel and equal, just like the parallelogram in fact. You could also say that the rhombus is a special kind of parallelogram because opposite sides are parallel, so yes, it is a parallelogram. Now what can be concluded about the angles of a rhombus? Let's have a look. Right, you can see here 85.9 and 85.9, so those pair of opposite angles are equal, and 94.1 and 94.1, those pair of opposite angles are equal. So for a rhombus, no matter what rhombus I make, the opposite angles are always equal. So let's write that down. Opposite angles are equal. Okay, so this angle here is equal to this angle here. And then let's use double arcs for this one. This angle here is equal to this angle here. So put those markings on your page. Now the one thing we didn't do, of course, is we didn't show that all the sides were equal. See? We didn't show that all sides are equal. So put a single dash there, single dash there, single dash there, single dash there. So all sides are equal. Let's have a look at the rectangle now. Now, for the rectangle, we know a couple of things about the rectangle, don't we? If we look, go to a little internet page and go slide next shape up, there we go, there's the rectangle. You can see the opposite sides, little arrows there, they're parallel. The opposite sides are also equal. And have a look, two red sides, they're parallel, so that pair of opposite sides are parallel, but also they're equal lengths, they're the two fours. So even if I make my rectangle smaller, right? That properties are still true. The opposite sides are parallel and equal in length. Okay, so let's write that down. Opposite sides are parallel and equal. Okay, so let's do that. We're going to put a single arrow there and a single arrow there, and then double arrows here, and then double arrows here, double arrows there, double arrows there. Now, how do we show that they're equal in length? Well, we've got to show that, actually just realize that is a mistake here. Opposite sides are parallel and, yeah, and they're equal. Yep, that'll do. That is correct. Now, when we say opposite sides are equal, we mean that this side's equal to this side, and then this side here is equal to this side. Okay, now what can be concluded about the angles of a rectangle? Well, you can see we've got 4 right angles here. Okay, so no matter what you do to your rectangle, how big or small you make it, you've always got 4 right angles. So let's add that to our diagram. Right angle symbol there, right angle there, right angle there, right angle there. So I'm going to write down 4 right angles for the angles. Okay, let's look at the square now. Now the square, let's go one up. There's the square. Well, opposite sides are parallel and all sides are equal. Okay, so let's write that down. Opposite sides are parallel and all sides are equal. Okay, let's just check that we wrote the same thing for the rhombus, because that was also true. So for the rhombus, let's just come up here. Opposite sides are equal. Oh, sorry, opposite angles are equal. So opposite sides are parallel, and let's just rub out the word equals here. We should put down and all sides are equal. Okay, so it should be the same as the square. So let's come back to the square now. Opposite sides are parallel. Let's mark that. So this pair of sides here are parallel. And then 2 arrows for this side to show that it's parallel to the opposite side here. 2 arrows there. Now all sides are equal, so we've got to mark that on there. So 1, 2, single dash on each side to show that. Now what about the angles? Well, we know that a square has 4 right angles, just like the rectangle. Okay, there we go. So 4 right angles. Okay, last of all, let's have a look at the, well, not last of all, nearly last of all, the kite. So if I go to the kite here, so let's go back to the web page, one up. Now have a look at the kite there. Let's look at the 2 blue sides. These are 2 sides which are adjacent to each other. And look at the 2 red sides. Those 2 red sides are adjacent to each other. You should notice that the 2 blue sides are equal in length, 3.6, 3.6. And the 2 red sides, which are adjacent to each other, are also equal, 5 and 5. Now, there's no parallel sides here. We can see that, no arrows. But you can see no matter what I do to this height, okay, no matter what I do, the adjacent sides are always equal in length. Okay, so the two blue sides of a pair of adjacent sides, they're equal in length, and the two red sides are adjacent and they're equal in length. So that's what we're going to write down. That it has two pairs of adjacent sides equal in length. All right, so let's mark that. So this side is equal to this side, and then this side is equal to this side. Okay, so you've got two pairs of adjacent sides equal in length. Now, what about the angles? Let's look at the angles here. Now, do we have any equal angles? We do here, these two 74.9s. These two angles here aren't equal though. Okay, so I've only got one pair of equal angles. Okay, so let's mark that in there. And those angles are opposite, aren't they? So we're going to say one pair of opposite equal angles. Okay, so let's mark those in there. So this pair here, this angle here, and this angle here is equal to each other, but this angle here and this angle here are different. Okay, so one pair of opposite equal angles. All right, last of all, what about the trapezium? Okay, for the trapezium, so we've got to go one shape up. There's our trapezium. You can see here we've only got one pair of parallel lines. So no matter what I do there, those two lines will remain parallel. But the interesting thing about the trapezium is I can actually make other quadrilaterals with it. Okay, so have a look at this. I can drag this so that I've got four right angles. Okay, now in fact I've got two pairs of parallel sides. So this is still a trapezium. Turns out a rectangle is actually a special type of trapezium. So this is what you typically see in the textbooks, trapezium looking like that, but it can also look like that. So because we can have two pairs of parallel sides, two pairs of opposite parallel sides, for a trapezium we would say you're going to always have at least one pair. So you need at least one pair of parallel sides, but you could have two pairs. So let's write that down. For the trapezium, we're going to say at least one pair of parallel sides. Okay, so this is the pair. Just there, one pair of parallel sides. Now what about the angles? Well, if you have a look at the angles aren't necessarily anything special. They're all different. Okay, so this angle here is different to this angle here, and different to this angle here. Now, as you saw, we can make this into a rectangle, so you might have all the angles equal, but they don't have to be. Okay. The other thing you should note, which we're going to use for the problem-solving part, so I'll put a question mark there for nothing special about the angles. We can actually write something about the angles. It's true for all the quadrilaterals, of course, but this angle here and this angle here, so I'll just do this one and this one here. All right, those angles are co-interior angles because we've got a pair of parallel lines here. And co-interior angles add up to 180. So in fact, if I call this angle A and this angle B, A plus B is 180 degrees. And same over here, if I had this angle here C and this angle here D, these two angles here, right, that angle there, this angle here, They're co-interior angles because of the parallel lines, and they also add up to 180 degrees. We're going to use that property, which I've written down here for you, in the following questions. Alrighty, so we're going to use the properties we just did up there and solve these questions. Now let's have a look. We've got opposite sides parallel. You can see by the arrow, so it's a parallelogram. So that means we know that the opposite angles are equal. Okay, opposite angles are equal. So let's have a look. We've got M must be 123 degrees, right? And we've got to put the reason, and we're going to say opposite angles of a parallelogram are equal. Okay. All right, now you can pause the video if you like and have a go at the next one. See if you can get the next one right. So let's have a look. So it's a parallelogram. And so you've got to think about the properties of the parallelogram. Right, you can see I've got a pair of opposite angles here. All right, just like before. Opposite angles are equal. So we're going to say that B is equal to 70 degrees. I'll put that down here. And I want you to write the reason down. So opposite angles of a parallelogram are equal. Okay, now see if you can figure out what A is going to be. You're going to have to use co-interior angles for this one. So have a think about the properties of co-interior angles. All right, so let's have a think about it now. Okay, so we've got, I'll change colours for this, so you've had to think about it. Now, this angle here and the blue angle, those are co-interior angles. We know they add up to 180 degrees. That means A must be 180 degrees minus 70 degrees, which equals 110 degrees. Okay, and so the reason we're going to put down there is co-interior angles on parallel lines are equal. Okay, so let's copy that down, and that's the first two questions done. All right, now let's have a look at the next one. So what kind of shape is this? We've got all sides equal, so it must be a rhombus. We've got to find out what x is equal to. And we know that for a rhombus, all sides are equal. So we're just going to write down x equals 8 centimeters, right? So 8 must be equal to x because all the sides are equal for a rhombus. So we're going to write down all sides are equal in a rhombus. Okay. Right, so you got the idea there. So what I want you to do is for the remaining questions, and we're going to go through those in class next lesson.